Okay, so just a second. Okay, so this project is related to dynamic rainfall forecasting using LSTM neural networks, a MATLAB implementation. So the MATLAB implementation is basically in the rain forecasting plays a vital role in the water basically resource management. So LSTM means long short-term memory basically, which is a neural network model is developed using the MATLAB to forecast the daily rainfall based on the historical data series. Basically, this system predicts the rainfall in uh, different areas according to the prediction of environmental changes in that specific area. So basically in this project we have just analyzed and we have just trained forecasting of data set of specific areas rainfall, and that data set when that data set is trained, then it predicts the next like we call it next prediction, and provides the next prediction when the uh, rainfall will happen in that specific area according to the different scenario. So in first of all we have just predicted a 30-day ahead forecast. So 30 days means we just predict that the next day's rainfall, how what the weather condition will be, and how the temperature will measures according to the based on the previous data set of the rainfall. So this is abstract with the keywords and introduction as well. Introduction also we have used a recurrent neural networks dataset. We called it RNN's method, and long short-term rainfall according to autoaggressive integrated moving average and multiple linear regression often fail to capture the complex temporal dependencies in rainfall dataset. So I have written the introduction of that um, paper, this article basically. So these are the just first introduction image, which basically provide us how the rainfall and runoff time series trend analysis using the long and short term based rainfall neural network model. Okay. So these are the just forward gate, these are the cell gate, output gates, and the input gates as well. So yes, we have just calculated its root mean square error values and improving the rainfall forecasting using the deep learning model. And these deep learning pre-processing models are basically the flexible to predict the actual rainfall during the next for the next day of that specific area. Okay, so here is the importance of rainfall forecasting. Basically we can cover the water utilities uses of rainfall forecasting for reservoir operations, and the use of attention mechanism is long short term networks also that can improve the accuracy of rainfall forecasting models. So these are the rainfalls runoff modeling using the long short-term memory basically. Okay, basically this is a prediction like how the generate batch of m random value samples, and then prediction, and then the parameters adoption and loss as well. Okay, so the challenges defined here, limitation and classical methods as well, and these are the tables according to the uh, interpretability, which can be both an advantage as well as the drawback of the rainfall. This model basically the prediction of rainfall as well. So here is a table which provide us the complete long short-term memory model with the other forecasting techniques as well. Okay, so it predicts the accuracy of our model is basically 94%, which is very high rather than other methods like ARIMA, ANN, SVR, kernel method, CNN, and other methods as well. Okay, so the advantages of learning and long short-term memory rainfall is that we can predict the accurate value. It's 94%, and it also provide us the seasonality and irregular patterns from the raw data. Okay, so a problem statement is here, like we can predict the accurate values of rainfall, and we can also use that rainfall in our water management system, crop management system, and we can also save the crop damage from the crop damage, insufficient food preparedness, and increasing the availability of meteorological dataset. Deep learning method basically such as long short-term memory network have emerged as powerful alternatives. So that's why we have just used that method to predict the actual rainfall forecasting using the MATLAB. So here is the mathematical approach in which data normalization added. These are the equations used in it. Network architecture, which is basically this: forget gate, input gate, candidate cell state update, output gate, hidden state, and everything. Prediction and training as well as the performance evaluation and the forecasting and visualization. So next part is the methodology. In the methodology, we have just predicted the accuracy of rainfall according to the like how or what methods we have used, what ratios, how many days we predict according to using of MATLAB's deep learning toolbox. Okay, so the detailed of methodology is added here, and it's a table of hyperparameter configuration and turning also added, which is basically input sequence length as well as hidden units, optimizer, learning rate, mini batch size, max patches, and dropout rate, validation frequency, activation function, and loss function as well. So in the design of methodology, we have used a CSV dataset in terms of different approaches, and that dataset provide us the original rainfall dataset. This is basically original rainfall dataset, and next part is basically forecast animation, and next part is basically prediction, which is actual scattered diagram, and residual plot as well. Okay, forecast animation according to the observed and the forecasting dataset, and these are the output results of forecast animation according to the different prediction rates. Okay, yes, this one also forecasting, observation, and training progress according to the root mean square errors. And results and discussion, basically the matrix and description is a valuation in it, like the prediction of rainfall dataset. And yes, these are the rainfall for 4 to 30-day rainfall forecast statistics. And next one is the conclusion, and references are also added in it. Okay, so let me just show you the output results of rainfall. These are the CSV file we have just used in our case, like these are the date mentioned in it, and yes, dataset of almost 1 to 2 years of dataset, which is basically provide us the rains Okay, 2 years of data set. And let me just check the output results for you. Yes, these are the MATLAB code. Let me just run it. You just need to run the rainfall forecasting using the long short-term memory based neural network dataset, in which we have just load and clean the dataset first, and then prepare input output sequence, then split the data and train validation task. Then we have just defined its long short-term memory network as well, and next one is the train network, predict and evaluate, as well as the visualization of actual, as which is the predictive data settles accordingly. 8 to 30 days with the animation of different days at different specific areas. Okay, the figure 1 means the original rainfall data set. Okay, see, these are the output results for training progress of the rainfall according to the iterations per Apache. Maximum iterations is 700, frequency is 20 iterations basically. Training validation and training smoothly as well. Learning rate schedule as well. So these are the final output results for the training progress of dataset accordingly. See, these are the prediction values. Predictive is basically dotted lines, prediction of red dotted lines of the rainfall. Actual is basically this rainfall. Okay. See, these are the prediction accordingly. So here you can run the MATLAB files and you will get the output results accordingly. Okay. These are the MATLAB results accordingly. Okay. Thank you.